Hi folks, and welcome back to Math with Captain Rod. This is meant to be video 2 here on a series of how to graph parabolic functions here. So we're going to take a look at this example right here, y equals minus x squared minus x plus 2. We're going to go ahead and graph it. Now some general observations here. You'll notice the number in front of the x is negative, so we know that this thing is going to open down. I'm going to do this one slightly different than the first two. We're going to do this one using the following form. And using the fact that the x-coordinate of the vertex, which is what I call h, I guess, by the other method, is given by minus b over 2a. The idea is we'll calculate this value, plug it back into the function to get the y value, and then we'll have the vertex, and we'll be off and running. So in this example here, right, h, the x-coordinate of the vertex, is going to be minus b, which is negative 1, over 2 times a. A is also negative 1. Be real careful with the minuses here. There are 3 of them, so the result is going to be negative. We get minus 1/2 out of that. All right, next what we're going to do is we're going to plug this into our function. So in other words, we're going to look at the function evaluated at minus 1/2. Now, another way to say this would be y at minus 1/2. Either of these are fine. So that's going to be minus, now be real careful with minus signs, minus 1/2 squared. This minus is inside the parentheses. This one is not, right, because of how this is written. Right, then minus for that one, x, which is going to be minus 1/2, and then right here, plus 2. A lot of minus signs in this. Be real careful with them. Now, negative 1/2 squared is 1/4, and there is a negative sign sitting in front of it. Minus and minus is plus, and then plus 2. All right, let's do this. Common denominator is a 4. Let's leave this one alone. Let's write this one as 2/4, because you have to multiply it by 2 over 2 so that it has a denominator of 4. Right, this 2, you can think of it as 2 over 1. We'd have to multiply that by 4 over 4. So that's going to be plus 8/4. All right, so we got here 10 minus 1, 9/4 out of that. So what we know now is that the vertex is at the point minus 1/2, 9/4. I'm going to go ahead and put this in my picture. So minus 1/2. Now 9/4 is 2 1/4, so 1, 2 1/4. There's my vertex, right about there. Now, because this is negative, we know this thing opens down. Before we sketch the rest of this, the X-intercepts would be just fantastic to have. Let's go ahead and get those. We can get those by solving, by putting 0 in for y, solving the resulting equation for x. This thing might factor. I'm going to multiply this thing by negative 1 first. Actually, I don't think it's going to factor. Let's just use the quadratic formula. Always works. Let's see, opposite of b, plus or minus the square root of b squared, that's going to be 1, minus 4 times a times c, all over twice a. Quadratic formula is a beautiful thing. So that's going to be 1 plus or minus square root of. All right, looking inside of here, this product is negative 8, and with a minus in front of it, that's plus 8 plus 1, so 9 over negative 2. So we're going to get 1 plus or minus 3 over negative 2. Let's take them one at a time. 1 plus 3 is 4 over negative 2. Which is negative 2. 1 minus 3 is negative 2 over negative 2, which is 1. All right, sorry about that. Glitches here when I bump stuff down here. All right, so negative 2, 0. Let's put that on our graph. Negative 2, 0. 1, 0. And that's probably enough to just sketch it. And again, the point of this is just how do you sketch these things. I'm just going to go ahead and do this. Good enough. Again, this is just a sketch. not meant to be a perfect picture. If you wanted more detail, you just calculate more points. Like maybe I put in 2 for x, or maybe 3 for x and get a y, and we could go here to maybe -1 and get a y value and so forth. You just put in more data points if you want a better sketch. Okay, the vertex is here. Let's talk axis of symmetry. That axis of symmetry looks like this. The axis of symmetry is x equals, now the x coordinate here everywhere, I think we found that earlier, is -1/2. So this thing is symmetric about x equals -1/2. The domain is all real numbers. I shouldn't tell you this, but I will. Any parabola that opens up or down is going to have a domain of all real numbers, right? Unless you put some sort of restriction on the domain for possibly physical reasons, if it's an application problem or something like that. But any quadratic function, math-wise, there's no values of x that won't give you a y value out, so domain will always be all real numbers. Range. Now here we typically look to our graph. Notice all the values for y are all below this point, so the range is y has to be less than or equal to this y value, which was 9/4. All right, so I think that's enough on this, and I'm just going to end this video now because I don't want these to get too long. I hope that this helps with how to sketch graphs of parabolic functions and how to find the equation for the axis of symmetry and how to determine the domain and range. So everybody watching, have a great day.